Hello everyone, I'm Armeen Zahra, an aspiring astronomer, and welcome to episode number 8 of Cosmic Conversations, a series where I have the privilege of speaking with scientists, researchers, engineers, and innovators who are expanding our understanding of the universe. Through these conversations, we explore their research, career journeys, and the ideas shaping the future of space science. Today, we have an extremely special guest, Miss Deniz. Miss Deniz, can you introduce yourself?
Yes, thank you so much. My name is Deniz Buyrukcu, and I am a graduate of the Department of Astronomy and Space Science at Istanbul University. And during my undergrad studies, I was involved in scientific research as well as astronomy education, and including teaching the astronomy through the workshops and educational activities. So, although I have a strong passion for astronomy and feel like that I can never really distance myself from that field, I am continuing with my academic journey with graduate studies in atomic and molecular physics. So that's me.
That's amazing. My first question was that astronomy is unusual because we often study phenomena we cannot physically interact with. We reconstruct the universe from photons, spectra, and indirect evidence. How has studying astronomy changed your understanding of the difference between what we observe, what we infer, and what we actually know?
Yes, actually, astronomy has changed my understanding of what it actually means to know something with certainty. I think before studying astronomy, I had more straightforward idea of what knowing something meant. So, astronomy, especially when you think about together with physics, shows you that observation and certainty are not always the same thing. Like quantum physics, quantum mechanics is a good example of this. There are fundamental limits to how precisely we can know certain properties of a particle at the same time. So, even at the most fundamental level, describing something as completely certain is not always possible in the way we think, expect. So, astronomy is space science. When we observe an object in the universe, we are not necessarily seeing as it's now. We are seeing the light that has traveled to us. Even the sun, which is very close to us on a cosmic scale, is seen approximately 8 minutes in the past because that is how long it light takes to reach Earth, to reach us. And when we study objects that are much further away, the difference becomes enormous. And this made me think much more careful about the distinction between what we observe and we infer from those observations and what we can actually say that we know. In astronomy, we cannot simply look at and something say, oh, this is actually how it is. No, we have to understand what the data is actually telling us and take into account the physical process involved and reconstruct what may have happened from the evidence reaching us. So I think studying astronomy changed my idea of knowledge itself. We are not trying to understand the universe simply by looking at it. We are trying to understand it through the information that the universe gives us.
Yes, I also agree with that. So the next question that I had was that, for instance, if you had access to an instrument capable of answering one currently unanswered question about the universe with no limitations on distance or sensitivity, what would you choose to investigate and what would you hope the answer would tell us?
Well, that's a good question. If I had access to such an instrument, I would choose to investigate whether wormholes actually exist and if they do, how they might form. At the moment, wormholes theoretically possible structures, and we do not have direct observation evidence that they are exist. But what would especially interest me that what they could tell us about the structure of space-time. If do they exist, they could fundamentally change the limits of our current understanding of space-time. What excites me more actually that this would not simply mean adding another object to our catalog of the universe. It could fundamentally change our understanding of physics, so it might reveal an entirely new type of particle or interaction that we do not discover before. So I think that's what I would be looking for, just a new answer. But I answer that forces us to ask better questions.
Yes, I also feel a lot of fascinated about wormholes. My next question was that the universe repeatedly forces us to accept things that conflict with everyday intuition, relativity, quantum mechanics, cosmic scales, and extreme environments. So, has studying astronomy ever changed your intuition about what is physically possible?
Yes, definitely. Like I mentioned earlier, studying astronomy has changed the way I think about certainty and about space time, but it also has it also changed the way I think about what is possible or impossible. Our everyday experience gives us a very limited intuition about space and about time, gravity, or a scale. When you study things like that, like black holes and neutron stars, relativity, or an early universe, you realize that what feels impossible to us may simplify something that lies outside our everyday experience. So, one of the biggest changes for me has been learning not to treat something as impossible simply because it conflicts with my intuition. Nature doesn't have to behave according to what feels logical to us. So now, instead of thinking that seems impossible, I try to ask, what does the evidence tell us? Or what is that? What's the evidence? So I think that shift in perspective is one of the most valuable things that astronomy taught me.
Right. And when you teach astronomy, you are not simply transferring information, you're also trying to change the way someone sees the universe. So, what is the moment when you know that a student has genuinely begun to think like a scientist rather than just simply like memorizing a fact?
When I teach astronomy in workshops, I usually try to explain things through the visual materials. I think children or anyone learns science much more effectively when they can see something, touch something, interact with it, or visualize an idea rather than only hearing information about it. So, uh, for me, the really important moments when a child starts going beyond the information I have given them. So, when they ask, "How does this happen?" Or what instead of what it is, or "How does it happen? How do we know that? Why does this work this way?" Like this one, and try to contact what they have seen with a scientific explanation. I know they're genuinely thinking about the subject. That's I feel they are beginning like a scientist because science is not only about knowing the answer, it's about being curious about it and about how and why we know it. So yes, when they start asking instead of what it is, when starts asking how, that's important for me.
Just like you mentioned, visuals. So, by visuals, you mean like simulations, diagrams, videos, something like that?
Something like that, and like the maquettes, like uh, about solar system or like constellation, like with some PowerPoints or with like how can I say that when they touch something they can see, like the minimal of like Saturn or the Earth, like when I paint that see the little balls with blue and yellow all are green, they can see the Earth. Of course, it's not Earth, and I'm trying to explain. Oh, that's if that ball is Earth. Can you think about that sun? It's already size of that room, and they trying to fill that blank with all the earth's size of earth, and they try to understand, oh, that sun is this enormous. So like that, like maquettes or like the little balls or like even the shiny stars that think about like they are constellations, so something like that. They all visual
Right.
items.
Okay. And you mentioned that you're studying both astronomy and space sciences and also human resources management. So, at first, those fields seem almost completely unrelated, but astronomy itself is increasingly collaborative and interdisciplinary. So, has studying both changed your understanding of what makes scientific teams succeed?
Yeah, of course. Like you said, astronomy is becoming increasingly interdisciplinary, and I think my experience in human resources that gave me perspective on that side of science, and it also works when I works with the children. I trying to understand how they actually think. So, of course, I'm no longer studying human resources. I left that program after studying for some time. But while I was studying human resources, I learned about how people think and communicate or work together. So I think that understanding is surprisingly useful in science because A successful teams need more than just a technical knowledge. It also needs communication and trust and people who feel comfortable with sharing questions or ideas. So although I love human resources, I still carry that perspective with into my science.
Right. And one more thing was that when we like tell people about astronomy, so they would say that they would think that we are observing galaxies and we are discovering spectacular objects every day. But much of professional astronomy involves mathematics, coding, statistics, data reduction, and sometimes years of work without an obvious discovery. So, what part of the reality of being an astronomy student surprised you the most?
Yes, thank you so much for your question. Like I trying to say that before studying astronomy, I thought being just observing the sky mostly involve observing the night sky. Of course, observations are very important. There is no debate about it. But a huge part of astronomy, a huge part of the work involves mathematics, physics, statistics, reading papers, and especially programming. That was the surprise for me because we don't actually see the object, and I was honestly surprised by how often we use programming to process data and analyze observations, create models, and even the see the results. So learning how to code has become almost as important and as learn as physics itself. So I was also surprised how much patient science uh, research requires. So sometimes you can just spend a long time working with data and trying the different methods and approaches before you get a result that actually makes sense. So I think that was one of the biggest difference between what I imagined astronomy would be like and what it actually studied in astronomy.
Right. So one of my questions was related to light pollution. So like what do you think that how has light pollution changed the way like astronomers observe like because before this century there were clear skies, like absolutely clear skies, but right now in the modern era we rarely see the clear skies in cities. So like how has light pollution changed the way astronomers used to observe?
In the past, um, astronomers could observe much darker skies and see many more stars with naked eye. And we know the Europeans or and other ancient popularities. I also use night sky and trying to understand what is the time, what is the river, just trying to understand what is actually means. So today, especially in cities, artificial light creates a bright background in sky. So many faint stars, galaxies, and other deep sky objects become difficult or even possible to observe. And as an astronomy student, when I was astronomy student, I think it's especially interesting because we can still study this object with a modern telescope and data, but we've lost that direct connection with the night sky that astronomy had in the past.
Yes. My next question was related to AI. So, AI is increasingly being used to classify astronomical objects, detecting planets, and also analyzing enormous data sets. So, do you think that AI will mainly become a tool that helps astronomers answer existing questions faster? Or could it eventually reveal scientific patterns that humans would not have thought to look for?
Well, yeah, I think it can both do because AI is incredibly useful when we have data sets that are simply too large for human to examine individually. So it can identify unusual objects and classify sources and detect patterns and help astronomers decide where to focus their attention. It also saves us a lot of time programming. For example, when we describe what we want to do, and AI can often generate the programming codes for us instead of having to write everything from scratch. So uh, but the more interesting possibility to me discovering something we were not specifically looking for. And if an AI system in that identifies and statically scientific scientific pattern that does not fit on our existing models, that could become scientifically very important. Of course, the difficult parts is then understanding the pattern represents a genuine physical phenomenon and observational effects or simply a problem in data. So I don't see an AI replacing the scientific process, and I see the potential expands the range of the humans are capable of noticing. So AI would not just help us to answer exciting questions faster, but also helps us to discover questions that we didn't know we should be asking.
Okay, thank you. And now my last question was that if you could give your younger self one piece of advice before beginning your journey in astronomy, what would you tell her? And what do you wish more young people understood about pursuing science?
Yeah, I would tell younger myself to not to be intimidated by parts of science that she doesn't understand immediately. And I would also tell her that struggling with something doesn't mean she isn't good enough for science. And if I give an example, as a bored and often quieted, if you think understand the quantum mechanics, you don't understand the quantum mechanics, and it's I think that attitude is very valuable because it reminds us our field and astronomy and physics is genuinely difficult. So of course science is constantly evolving, so that is why I think it's very important for young scientists to stay curious and keep learning and adapt a changing world. And AI is a good example of this. So I have done a small study on people's perception of AI, and I think its presence our lives is now undeniable. So learning how to use it effectively is very important, but I don't think it should be go beyond being helpful too. So we still need to think the question and do the work ourselves. And finally, I will tell them not to disconnect from social life just for working hard because you don't have to figure everything out immediately. With time and curiosity and yeah, and work, things start to fall into place. So yes.
That is such an amazing advice, and thank you so much for being here today and like taking out your precious time to give me this interview.
Oh, thank you so much. That's a pleasure to me. So, and thank you once again for inviting me. And give me the chance a part of this project. And it was an interview that I am truly proud to have been a part of it. So I wish you continue the success with your work, and I'm sure you will go on achieve great things.
Thank you so much.
Thank you.